Okay, so this video is intended to review a lesson that we designed to give students an introductory surface level view on every single topic that comes up on the algebra region. So over here you'll have a list of topics. And then in the lesson, you're going to have one or two questions on each topic. This is a primer. It's a surface level to build up your general knowledge, and then we'll build on this in the lessons. This video is designed for teachers that need to learn the best methods to teach the students these questions and the best systems, or for students that came to the free lesson and now want to review this lesson. And if that's you, then congratulations for taking that step, and this is really going to take you in depth. So it's going to move at a brisk-ish pace, but hopefully you'll all be able to keep up. And if you can't, then you just rewind, and you can watch it on again and again until you really have a knowledge of how this works. Okay, so the first question asks to subtract 3x from the minus 21. The real issue that I notice most commonly is people don't understand what from means. The example that I'll always give is, imagine it said subtract 5 from 3. Well, then you would understand then to do 3 minus 5, wouldn't you? Okay, so same idea here. Subtract from means subtract the second from the first, and this is most commonly how they ask it. That trick is designed to get them making a mistake. So once they know that, then they could set it over here. So they have minus, right? Minus, that's a key minus. 7x squared plus 3x minus 21. And then they need to know to distribute that minus sign. That's important. Some of them, people will teach it to do it each step. I say just distribute it up front. So it becomes minus 7x minus 3x, right? That goes away. And then this one becomes plus 21. Then you subtract. You get negative 6x squared plus 3x plus 17 as your answer. Okay, so that's the answer there. All right, on to the next one. Express the product. The way that we teach this, I think this is a very good way to teach it. Some schools teach it this way, some don't, is to draw a box like this. So it's basically, this is a more advanced level of foiling. Foiling is 2 by 2. We're going 3 by 2. So a trinomial by a binomial. You create a box that goes 3 by 2. And then what you do is you put the 2, let's get this level going. Okay, good. And what you do is you do x over here, 3 over here, it's positive, and then 3x squared minus 5x here, minus 10. And then you just do this one, 3x cubed, x times minus 5x minus 5x squared minus 10x. And then here you would get 9x squared. My handwriting is disgusting, so hopefully you'll be able to still follow me, minus 30. And then you do something called combining like terms. So the 3x cubed is the only of its kind. So that's going to stay on its own, 3x cubed. The x squareds, there's 2 of them, and make sure they understand why these are like terms. So this one you'll say plus 4x squared, right? Not minus 5 and 9. And then you have the 10x and the minus 10x and the minus 5x is going to become minus 25x. And then the last one is going to be minus 30. And that will be your answer. Okay, next question. The next thing that you need to know how to do is factoring. We start with a question that's a little bit more, it's not advanced, but it has one extra step, and that is if you ever see a number before the x, the first thing to do is try to divide that number out. And what that means is 3 divided by 3, that comes out evenly. 12 divided by 3, that'll be 4, and minus 15 divided by 3 will be 5, so this works. So because of that, we're going to divide everything by 3. We call it pulling out a 3. And you'll have 3x squared plus 4x minus 5. And then now that you got rid of that 3, now you're in a position where you can factor it. Now to teach factoring, this is very important. It's a basic way that we like to teach it. all students know it multiplies to that and adds to that. But what we like to do is we like to go by the sign and say, look at the second sign. What is it? In this case, it's negative. Now, what kind of numbers could multiply to a negative? Well, only a negative and a positive. So I know that it's going to be x plus, and students do have a hard time learning how to factor, and x minus. Now that I know that, well, I can make a list of things that multiply to 5. It's really only 1 and 5. And the rule is that the bigger number gets the inside sign. So 5 and 1, because 5 plus negative 1 would be 4. 5 times negative 1 would give you negative 5, okay? And the next question takes it another step and asks you to solve for x. The reason you solve here, some students don't realize, is because it says equals 0. So that's an important rule. So now we, again, look at the middle sign. And again, this is negative. So again, that tells me that I have an x plus and an x minus. And then the things that multiply to 16 would probably be 1 and 16, 2 and 8, 4 and 4. Which ones could possibly add up to 4 on this list? None of these could add up to 4 on this list. It appears that there is a mistake in the question. So let's leave this question and let's actually try to do another example of a question. So the previous question had a negative, so what I'd like to do is give the students an opportunity to see how the factoring would work in a situation of a positive. So let's say we had something like x squared plus 6x plus 9. The second sign in this case, which we go by, is positive. So what that tells me is I'm going to have what kind of things multiply to a positive? Either a positive times a positive or a negative times a negative. Then you look at the middle sign. Because the middle sign here is also positive, I know it's going to be positive and positive. And then you make the list, it would be 3 and 3. So that's that. Again, if you need to go slower for factoring, students definitely find that to be a challenging topic. Okay, on to the next question. Completing the square is an important way of factoring. This is something even you might not be familiar with, so pay attention carefully. And we'll discuss why they also call it, put it in vertex form. But whenever it says vertex form, that's key for perform completing the square. Completing the square is a way of factoring that gets you the result. So let's look at what you do. Step 1 would be to isolate the x's. Move that 6 over to the other side. So you subtract 6. So you should have x squared minus 4x equals minus 6. Now what you're going to do in completing the square is you're going to add a certain number to both sides, a special number. Now what number is it going to be that you're going to add to both sides? What you're going to do is you're going to take the inside term, this is the minus 4, divide it by 2, that'll give you negative 2, and square it, which will give you positive 4. Now, why do I do this? I have no idea. This is what it's called completing the square. You're completing the square. Now, what you'll see is that this thing on this side, this term here, is something that you could factor. And when you factor it, let's just factor it the way that we just learned, and you'll see what happens. So what we'll say is, again, it needs, the second sign is positive. It's positive, positive, or negative, negative. The inner sign is negative, so it's got to be 2 negatives. So I know I have x minus something and x minus something. You make the list of things that multiply to 4. It's just 1 and 4 and 2 and 2. You can do it on your calculator. The ones that are going to add to negative 4 are 2 and 2. X minus 2 and x minus 2 equals negative 10. Now, x minus 2 times x minus 2, a fancy way to call that is called x minus 2 squared. This is why it's called completing the square, equals negative 10. You bring this over to the other side and you have x minus 2 squared plus 10 equals 0. Now, why is this called vertex form? Because, well, let's discuss what a vertex is. A vertex is a point on a parabola, either its maximum point, in this instance, or if we had a different kind of parabola, its minimum point. It's the point of the parabola, and it'll have an x comma y coordinate, meaning it'll have a location that exists x comma y. Now we're going to teach you how to find that using a graphing calculator, and that's an important way to find it. But there's another special way to find it, and it's by doing this thing called completing the square and getting it into vertex form. How so? Well, right now I have that this is the equation of my line in vertex form. What does that mean? What it means is that the coordinate of the vertex actually is going to be the point. Oh, -6 plus 4, by the way, and if you caught me, that's actually also equal to negative. That's equal to -2. And then when you brought it over to the other side, it should become +2. So the coordinate of the vertex, the x-coordinate is going to be the opposite of this number, a 2, because it's in parentheses. And then the y-coordinate is going to be whatever this number is, which is 2. So in this case, it came out to the same number, but if we did a different example, let's do one other quick example of completing the square for vertex form. Let me just give it to you. Let's say I had x minus 3 squared minus 6 once I did vertex form, right? What is the coordinates of the vertex in this case? So the correct answer would be 3, 6. And what that means is if I go to the graph and I look at the point 1, 2, 3, -6. 3, -6, that'll be the vertex of my parabola. Okay, so that's called vertex form, done by completing the square. Okay, the next thing here is just some basic algebra. Students need to learn how to cross multiply or multiply this over to the other side. They like, to see it as cross multiplying. You could also teach them that they could simplify right here to 2, and that'll really make the process easier. Then you do 2 times x minus 2 equals 2. They have to know how to distribute. It's something that not everyone knows how to do. Equals 2. Add the 4 to the other side. Plus 4 plus 4. 6 equals 2x. Divide by 2. X equals 3. And that'll give you the correct answer. Okay, so let's go on to the next question now, another bit of algebra. This is a type of question they like to ask on the Common Core. It's important to teach the students this trick. Now, how do you move this number over to the other side, this 2 over 5? So some students will say divide by 2 over 5, maybe they'll distribute it in, and it'll be a mess because it's a fraction. What you could teach them is that they can multiply by the reciprocal to both sides. And when they do that, and they don't really have to understand why that works, but when they do that, this will cancel, and then you'll just get x minus 3 equals 60 over 2. X minus 3 equals 30 plus 3 plus 3. X equals 33. And there's another example on the next one of exactly that, so you could try it again. You're multiplying by the reciprocal. Okay, it's a nice trick that students find very helpful. Variable manipulation. They're asking you to solve for a. Now, for some reason, understandably, students have a much harder time with this than if numbers. So I always like to show them, well, let's say it was a number. Let's say it said 3a squared equals CD. What would the next step be here? And you'd say, oh, obvious, divide by 3. Well, same thing here. We want to solve for a squared, so we're going to divide by b. And then once we divide by b and we have a squared equals CD over b, next step is to take the square root of both sides. And a equals that is your final answer. Okay. Graphing is the next section, so this is all going to require a graphing calculator, and it's going to teach them how to use a graphing calculator. It's a critical section, the place where I think the easiest points to be had are. Now, I didn't love how this question worked out, so I changed 2 of the numbers, and hopefully in the curriculum that you have in front of you, it has the updates. But this number here should be x squared, but this one shouldn't be 4x minus 8. It should be x plus 2. So they're asking you on the axis below to graph these two things and then to find out where they intersect and which one will have a greater value when x equals 20. Now, one of the challenging things for some students is, the introduction of this idea of functions, right? So what is f of x? F of x is just this f of x. What is f of x? F of x is just y, right? And we'll explain functions in greater depth, but it's just y equals, graph both of them. So I'm going to show you exactly how you would do that. So right over here we have it. I would graph x squared, and the way that you would get it onto a paper nicely is that you would want to see the table. So you'd press second table. Here you would just do it like this. And these would be the list of the points. Now, you should copy down these points from -2 to 2, exactly these points, onto your piece of paper. Okay? That's the table you'll get it from. And then you would graph each of these points individually. -2, 4. -1, 1, 0, 0, etc. Then x plus 2, you would do the same thing. You would get the table, and then you would graph it. And then they ask you the 2 points that it intersects, so you could see it's the point -1, 1, and the point 2, 4. Then they ask which one will have a higher value, y value, right? Which one will have a higher y value when x equals 20. So you could just picture which one is going up quicker. It's the red, the exponential graph, the x squared. And we'll talk about linear versus exponential, but you could see that as a very small amount of x change is creating a huge amount of change in the y. So that is that. Okay, so that's that graphing question. Now let's look at the next graphing question over here. It's a graphing and inequality question, and students are going to love the way we show them to graph these inequalities. So question number 12, you go to your calculator, and what you should do here is you should graph it and teach the students how to use the less than or equal to button for the x plus 3. So once you teach them how to do that, use the less than or equal to button, they're going to be very excited to see that it shades in for you. You actually don't need to know that much about shading. And the same thing with the -2x minus 2, you'll graph it. So you graph one at a time. Again, you get the table, and make sure that they're meticulous with this, because any sloppiness here will lead to a loss of points, and it would be very frustrating. So you want to get it, you want to graph down the points, and then you want to shade on your own graph, and then you want to do the next one. And again, you want to graph. And the places where they're equal, which they'll ask a lot of times, they don't ask it here, is this area here where it's both red and blue, or on their graphs it'll be a jagged dotted line or something like that. Okay, so that's that question type, again using the graph. 13 says, what is the function of the the 3, the coefficient 3? Now I would do this by graphing. I don't have such a good memory, but you could memorize the rules. That's also definitely an option. But they're asking you, what does the 3 do? And then you can look, does it move it higher? Does it move it lower? Does it make it wider? Does it make it narrower? So again, I would graph it. First thing that I would do is I would graph the standard x squared without the 3. You get that graph. And then I would graph the 3x squared, and what do you see happening? It gets narrower. So the answer is that it makes the graph narrower. That's going to be choice D. Counter to what you would think, right? It makes it narrower. Interesting. Okay, so again, graphing though, you could really accomplish a lot. This final one asks you to graph these, which inequalities graph. Below, I would graph each of them. So for the final graphing one, you go here. Does this look like our graph here? No, it's the opposite. Does this look like our graph here? Yes, it does. And you can check points. Check points, okay? Very important. All right, intercepts. A lot of students don't know this. Intercepts, so they'll ask you for the zeros of this function. Now, what I like to teach students is, what is a zero? A zero is an x-intercept. What is an x-intercept? It's where the graph intercepts the x-axis. So you could have them graph this, and then we're going to teach them how to trace zeros, okay? And it'll be the x-intercepts where it hits the x-axis, okay? So that's that. Do that graphically. Another way to do this, by the way, is you factor. So you would factor, it would come out to x minus 15, x plus 2, and your intercepts would actually be x equals 15 and x equals negative 2. So either graphically or very easy by factoring and solving for when y equals 0, right? You're plugging in a 0 here, and then you're solving, because when y equals 0, that's the point that would be called an intercept. Okay, let's go to the next question. This one asks you about the vertex of the equation, determine whether it's a maximum or a minimum. Again, I'm going to have them graph it, and I'm going to teach them how to trace maximum. You're going to have the left bound, right bound. If you didn't figure out how to do this during your lesson, left bound, you want the trace to be on the left of the point you're looking for. Right bound, it sandwiches it, and then it'll give you the value of the vertex. The other way to do it would be completing the square, but here to factor this would be a nightmare. We can't pull the 2 out, so that's going to be the way that we're going to have to do it graphically. 17 asks for the domain and range, and the way that I would do this is also graphically. They want to know, determine the domain of the function. So let's graph this and see what happens. Okay, graph it. It's negative, challenging. Now, what you'll be able to see once you zoom out eventually is that, they always say domain means what values could y be. But what they mean by that is there's a limitation on the options for what y could be. What are the limitations? Could y be anything? No. There's a certain point up here that's so high that y can't be it. So what you would need to do is trace this maximum and realize that y could only be a value lower than this maximum. Y could only be a value that is lower than that maximum. So that's something that you would explain to them. Let's look at another question that won't be so high up maybe. So we want to graph the absolute value of 2x minus 4. Okay. Now, again, is there a limitation in terms of the y, of what y could be? Like, could y be 4? Yes, y could equal 4, right? That wouldn't be a problem. Y does equal 4. Could y equal negative 4, though? No, it can't. Y is capped at 0. So the domain then would be that y always needs to be greater than or equal to 0, right? That's the cutoff point. Y can't be anything that's less than 0. So you graph it, you look for that. Now, in terms of the range, though, no matter how far we zoom out on this graph, you are going to see x continue because x is going infinitely this way and infinitely that way. So the range of this function, the x values, would be x could be all real numbers or all numbers, they could say. So that's that. All right, next, linear functions. This is probably the easiest and most important topic that comes up on the test. It's something that's definitely worth us exploring in more depth. So let's just take a random example here of we'll take the question actually. So it says that y equals 18x plus 20. Plus 20. Now, we've all learned before that you have something in a line, the formula of a line is y equals mx plus b, where you have a y-intercept and a slope, right? Y equals 18x plus 20. We know that this is called our slope, our y-intercept, sorry, and this is called our slope. Now, what do these concepts mean? That's what this question's asking. So what I always like to give an example of is, let's say I told you this. Your test score right now, before you start preparing for the Regents, is starting at, let's say, a 40, right? You would start at about a 40 without any studying. And then every hour that you studied, your score would go up 2 points. Every hour you studied, your score would go up 2 points. The way that would be graphed is y equals 2x plus 40. 40 is the intercept. It's what you're starting. Even if you study 0 hours, you would still have a score of 40. And then every 1 hour you studied, your score would go up 2 points. And that's what the slope means. So now let's look at the question here. She deposited a certain amount, then it's going to grow. So what she deposited was, she deposited the $20. That's the amount that she deposited. And then every amount of time, her money went up by 18. So what was her initial deposit? It was 20. That's a very, very important topic. Okay, let's look at the next one again. So a man joins a cell phone plan that has a startup fee of $25. Startup fee is the amount that he starts with right away. I know that's going to be the y-intercept and an additional charge per month. So it makes sense. Y equals this per month charge has to be multiplied by the number of months plus the startup fee. He starts at being charged $25 and goes up 0.3 each month. So the answer is 0.3 plus 25. These questions should be, they're important questions. Okay. The next question is, how much more is the car worth? Oh, wait, so we have another exponential interest question. Yes. Okay, so this is a new type of formula. It's exponential. Now, there's two different ways that you could increase something over time. Like imagine I told you, would you rather me give you $10 today, and actually, would you rather me give you $1,000 today, and I'll add on another $20 every day, or would you rather me give you, on the other side, I'll give you $2 and I'll double it each day? Well, some of you might think, I'll take the 1,000 plus 20. So 1,000 plus 20 on day one, on day zero, you would have 1,000. On day one, you would have 1,020, and so on. But look what would happen to your money if you doubled it. On day zero, you would have 2. Then you would have 4. Then you would have 8, 16, 32, 64, 128, 256, 512, 1,024, 2,048, 4,096, 8,292, and so on. This number is going to balloon. This is called exponential growth. This would be linear growth. You would be going up the same $20 every month. $20 every month, a month, $20. That would be a linear equation. Whereas this one would be exponential. It would be growing quick. At first, it would just get slowly bigger, but then soon it would rapidly shoot up to the sky. So we have this here, and the formula is very simple. It's A, the amount, equals the principal, what you started with, times 1 plus or minus the rate to the time. Now, in this case, his principal is the 25,000 that he started with. A equals 25,000. His rate is 7%. How do you write that as a decimal? 0.07. So you would have 25 plus 1 plus 0.07, and the amount of time would be 15. That would be, and then you just throw that into a calculator. And the next question is identical, so we're going to skip it for now and move on. Linear versus exponential I just discussed. So now when you look here, is it that we're consistently going up by a fixed amount? Well, how much are we going up here? We're going up 900 we're going up. How much are we going up here? Oh, we're going up 9,000. How much are we going up here? Oh, 90,000. This then is not going up by a consistent amount that you add each month like in a linear equation. It's going up by more, and that's why that'll be an exponential equation. All right, let's look at that. And it's growth because it keeps getting bigger. And then when you look at this, it says it increases at a constant rate, 1 pound per hour. Constant rate, 1 pound per hour, that's a slope of 1. That's a linear equation. So that would be choice E, the linear equation. Okay. Let's look at average rate of change. It's just a keyword for slope. So what you would do then to solve these problems is you would just be taking the slope. Now, let's show how that looks. So you make sure the student knows that by heart. What is average rate of change? Average rate of change is slope. Let's look at it here. They say calculate it from when it starts until the 4th hour. So, y2 minus y1 over x2 minus x1, that's the formula to calculate slope. So if one of our points is 0, 26, f of x just means y, 0, 26, and our second point has the value 4, 5. So let's do the equation. y2, 5, minus y1, 0. x2 is 4 minus x1, 0. I'm sorry, it's 5 minus 26. 5 minus 26. So you would get negative 21 over 4, that would be your slope. It's a negative slope. That would be considered your average rate of change, and that comes up all the time. Word problems. A student has to buy new books. The cost of each book is 5 and the cost of a pen is 0.3. So 5 times the book plus 0.3 times the pen. This one they're asking, they want to know how many weeks will they have the same amount of money saved. This just means set the equations equal. So you could do it algebraically or graphically, graph and check. These look like they're high numbers. It would be hard to do it on the graph. So I would probably set 60 plus 5x equals x squared plus 46, right? One of them saving his money linearly, one exponentially. You would solve by bringing everything over to that side. So x squared minus 5x minus 14. You would factor and you would get 7 minus 7 plus 2. And there's no such time, so you would get two answers, -2 and 7, but is there such thing as -2 weeks? No, there's not. That would reject, and the answer would be 7. Okay, moving along. I've been taking my time, but I really want to show you the methods of how we do this, so it's very important that you watch all this. System of equations. Okay, to solve a system of equations, you have two systems. The goal is to eliminate one of the terms by adding or subtracting them by each other. So, for example, here, you would just add the two equations, and what you would get is 7x, and 3y plus 3y would disappear, equals 14. You would solve for x equals 2, and then you would take the 2, plug it back in to one of them, and solve for y. Okay, now sometimes they'll be a little bit more complex. Okay, so that's actually one method. Now, another method for solving a system of equations, that one was called elimination. Another method for solving it is going to be called substitution. And that'll be done when you have the equations that look like this. They tell you that y equals x plus 40, so we could go to the previous equation where it says y, and we could replace it with x plus 40. So now we have x plus 40 equals 250, and you would solve that out. 2x plus 40 equals 250, 2x equals 210. I subtracted, divide by 2, x equals 105. Okay, hopefully I didn't make too many mistakes in these videos. Okay, now here we're going up levels. Okay, each time we're going to get a little bit harder and a little bit harder. So he said that it costs $235 to care for a lion, a monkey, and he noticed that they spend $8, $9, $50. Write an equation. So the equation's simple. It's 2.35 times the monkeys plus 550 times the lion equals 89.5. The next step then, that's the answer to question 1. Now question 2 says, Frank said that there have been, sorry, this is, I just want to, Frank says there may have been 10 monkeys and 15 lions. Would that work? So you would plug in 10 for the monkeys, and you would plug in 15 for the lions, and you would solve to see if it equals 89 point whatever. You would see that it actually does not. So that wouldn't work. And then for the next one is the hardest last part of this question. Says later he found out that there were 22 monkeys and lions. It doesn't mean each, it means total. There were a total of 22 monkeys and lions. So now you have another equation. The second equation that you have is that the monkeys plus the lions equal 22. Now this is a system of equation. You could either do elimination, multiply by 5.5, you multiply everything by 5.5, or you could do substitution. Okay, that's a pretty challenging question though. Which graph represents a function? Okay, so before I would get into looking at graphs and seeing which one represents a function, I would just talk about a function in general. And the most basic function that we could talk about is the function of, let's say, f of x equals x plus 3. Now, what a function is, and you always hear that f of x equals y, but what it really means is this. It's like a little machine. I'm going to plug in some number for x. Let's say I plug in 0. Now, when I plug in 0 for x, what am I going to get out? Well, I'm going to get 0 plus 3. I'm going to get 3. So when I plugged in 0 for x, what was f of x? Oh, well, f of x was 3. Okay, what if I plugged in 1 for x? Oh, you would get 4. Okay, so this is x comma y points. It makes sense. Now, how would I know if this machine was broken? If I put 0 into this and it popped out 2 values for y, like I put 0 in and I got 3 and 8, then there's something wrong and it's not a function. Now, the way that looks graphically is called it doesn't pass the vertical line test. So you look at these and you draw the vertical line, just a straight vertical line, a nice vertical line. And you could see in this graph, if you drew a vertical line, vertical means upwards, think of someone's vertical leap in the NFL Combine or something like that, you would hit 2 points. It wouldn't work. Here, same thing. It would fail over there. Here, it would fail all the way along the way. This one, it wouldn't. Now, that's graphically. You could just do the vertical line test. But they're also going to ask you to understand it like this. So if you added one of these points, which one would it not, which one would not be a function? Well, if I added -3, then I would have the point -3 comma 1 and the point -3 comma 2. Well, if I plug x into the machine as -3, which one is it? Is it 1 or is it 2? That would be not a function. That one would ruin it from being a function. Inequality word problems. You have to learn how to write these out. It's not the most complex, but it's an important idea. So there's a setup charge of $35 and the cost per person is 15. So it's going to be 35 plus 15p. And it says that he wants the maximum budget is 150, so it needs to be less than or equal to 150. Now, they were mean. They didn't have any choice like this. So you would have to do, this is 15p. So you would have to solve, you would subtract 15p, and this would be the answer. They made you do another, this wouldn't be the answer. They made you do another step. It would be this one, 35 minus 15p, because this has to be the maximum number. Graphing word problems. So this is like a system of equations. He must sell 2,500 printers and computers per day, and each printer costs 50 in computer. So it's 50 times the printer plus 500 times the computer has to equal 2,500. And then he has to ship a maximum of 15 items. Oh, it says must sell at least. So it's got to be greater than or equal to. It's got to be at least that. And then he could sell printers plus computers as long as it's less than or equal to 15. And then you would graph both of them. You would look and see where they intersect, and that would work, okay? 34 is the sum of this rational. Irrational just means the number goes on forever without stopping. 35, I think the question is broken. 36 is the idea of correlation. What I like to say is this. You're in this course, and hopefully, if we did a study on people in this course, what we would find is that the more hours that they spent studying in this course, the higher their score would be. So, in general, if they came here without the course, they would score around here. And generally, as the more they were at the course, their score would go up generally. Now, there would, of course, be some outliers, some geniuses that did well without coming, and some monkeys that did horribly despite coming. So the correlation wouldn't be perfect, the relationship wouldn't be perfect, but if you drew a line to approximate what it would look like, it would look something like this. It's called the line of best fit, and the correlation says, well, how well does the line of best fit model the data? This one would probably be about 0.8. It would be a pretty strong positive relationship. Correlation goes from -1 to 1. 0 is the least correlation. 1 is the strongest positive relationship. We had a 0.8. The strongest negative relationship would be something that had a negative slope. So choice Y, that's a negative association. As the more hours you spend in my course, the worse your score is. Obviously wouldn't be good. But this one you got to do on L1 and L2 on the calculator. And then you need a EXP reg. I don't have that in front of me, but you should know how to do that. And I consider that close to 3 points. Residuals. So remember we had our discussion about correlation. This is only if you want to understand it. If you don't, then I'll just explain to you easiest way. But if we had some kind of, loose correlation, and then we drew a line of best fit between it, there would be some difference between what the reality and what the line says. So if you subtracted the distance, you would get some numbers. Now, if those numbers had a definitive shape or form, a pattern, like choice B and C do, then your line of best fit was not good. So which one suggests that linear regression would work? The answer is actually A, because B and C say there's something wrong in a pattern. So if there's a pattern, it didn't work. If there's a pattern, it didn't work. Series and sequences without knowing any formulas. A lot of students memorize these ridiculous formulas. What is the formula for the nth term? All we do is we test. So this term is called term number 0. This is called term number 1. This is called term number 2. So what you do is you just plug in, and this is called n, the number term. You plug 0 in. Plug 0 in. 8 plus 2 is 10. Did that work? Yes. 8 plus 1 is, oh, I'm sorry. This is called the first term. I'm sorry. This is called the first term, so I made a little bit of a mistake here. This is called term number 1. So you would plug in 1. Does 1 plus 2 equal 10? Yes, it does. Does 2 plus 2 plus, right, you plug a 2 in here, you get 4. 8 plus 4 is 12. Does that work? Yes. And so on. This one would work. Okay? So this would be actually the one that just works flat out. You just plug in, or you could graph it and check the table another way. Recursive sequences, right? So students have a hard time with this also. You just use the previous term. It's not really complicated. You have, this is 5 and a fourth. That's weird. Just make it 5.25. But you have this an minus 1. I don't know what that means. So you just plug in this previous point. It's 2 times 5.25 plus 1 equals something. What does it equal? It equals 10.5 plus 1 is 11.5. Then you just do it again and you plug what you got back in. That's just how it works. So now it would be 2 times 11.5 plus 1. And this time what would you get as your answer? You would get 23 plus 1, 24. And you just plug it in again. So now we have 2 times 24 plus 1. What would you get there? 48, 49. Then you'd plug it in one last time, and you'd have 2 times 49 plus 1. You would get 98 plus 1 is 99. You would get 99. These are your first 4 terms. You have 11.5, 24, 49, and 99. Okay, so it seems complicated, but in reality, it's not. Okay, for this question, this could be a hard question, so let's look at it. They say that they have a rectangle and that the rectangle measures, so let's draw a rectangle, and that the rectangle measures 6 by 8, okay? Now they want to put this rectangle in a frame, and they want the frame to have a maximum area of 100, okay? So now, the first question is, write an equation that could be determine the maximum width of the pieces of the wood frame that he could use, and then explain how it models the situation. So this is the way to understand it. The area right now of the small guy is 6 times 8, right? Is 48. The area of the big guy is going to be 100. Now, the way that you're going to get to the big frame is by adding a frame here, right? And adding a frame here. And also by adding a frame here and adding a frame here, right? So, and then they say that the pieces of wood are all the same width. So what that tells me is that this is called X and this is called X, and that this is called X and this is called X. Now, how long, this used to be 6 long, how long is it now? It's 6 plus 2X. How, this used to be 8 long, how long is it now? It's also 8 plus 2X. So the rule is to find the area, you have to multiply them by each other, and they should be maximum, so they should be, that should be less than or equal to 100. And then you solve, factor, and solve. And then the last question on this curriculum is about mean, median, and mode. So what I like to say is this. I could tell you that the mean income in the U.S. is $100,000, the mean being the average, right? But that really wouldn't tell you that much, because it's possible that everyone in the U.S. makes $100,000, or it's possible that some people make 0 and the rest of the people make $200,000. You understand? So that's why we need other statistics. Now the median is a pretty nice number because it tells us what is the middle number in the class. So that means that half of the people make more than 100,000, half the people make less. That would be very informative. That would be telling me a lot, whereas the mean wouldn't. the mean is very impacted by outliers. So if someone makes $1 billion, he's going to pour up the mean drastically. Whereas the median, half the people are above, half the people are below. So if there's someone with $1 billion or $100,000, it doesn't impact the median that much. So in this question here, the 24-inch measurement won't really impact the median. So which will be changed most? The mean actually would be changed most by an outlier. Okay, so that's it. If you're a staff member, make sure to be patient, explain things in the best method that you can. And if you're a student and you just watched this to review after you came to the free lesson, you're one of the most motivated students that we have. We'd love to have you join our course. So click on the link that'll be on the page right here. Definitely sign up for that immediately. We'd be so excited to have you. Thanks for watching.